Hello students, welcome back to the lecture series on Introduction to Scilab Software. This is video part 13 and we are solving question set 12. As I have said earlier that you should know the basic concepts or some of the knowledge of the matrix algebra. Reduced row echelon form of a matrix is obtained by performing elementary row operations on the matrix A. Now what are the elementary row operations? We can interchange any two rows is the first one, or we can multiply any row by a non-zero scalar is the second, or we can perform operation like adding scalar of one row to the another row. So this is the reduced row echelon form. Of course here we are just doing it by means of a command. So let us declare the matrix A first. I'll tell you where we are going to use it, and it is very useful while solving the system of linear equations, the reduced row echelon or the row echelon form. So the first matrix you can take, let us take the D question first, then we can solve the rest of the questions. We can take it as capital D for our convenience. It's a matrix of order 3 by 3, 1, 1, 3, and this is 3, 5, 8, and 2, minus 1, 3. So this is your matrix D. So for reduced row echelon form, the command is RREF. So RREF of D. So this is the reduced row echelon form, which is like identity matrix. So after performing series of row operations on the matrix D, we are getting this. That means at first position 1, then below zeros, then 1, the pivot position in the second row, then below 0 and above also 0, and the last is 1, and above the pivot position we should have zeros. So let's just do the first question. This is not the only row echelon form where we are getting the identity matrix. Let us take the C question, where we have a matrix of order 3 by 4. That means a rectangular matrix 3, 7, 0, 2. So there it is not going to transform to identity matrix. Minus 1, 8, 5, 2, and then 9, 2, 11, 4. So this is the matrix C, and the reduced row echelon form RREF of C is this matrix. So as you can see, in the first 3 columns we have 1 as the pivot position, and the rest of the entries in that column are 0. So we have 3 rows, and in each row we have a pivot position, but the pivot position is not there in each column. So the last column does not contain a pivot position. So this way, this is the simplified form of the matrix which is used for solving the system of linear equation. Let us do the B question. Now B is equal to 0, 1, 2, 1, then 1, minus 1, 0, 2, then we have 9, 2, 11, 1, matrix of order 3 by 4. Now RREF, the name of the matrix is B. The name of the matrix is B here. So this is also pivot position in every row, but not in every column. So A question is for, just consider it for homework, and let us solve the question E as 1, 2, minus 3, 2, 2. It's a matrix of order 3 by 5. So let us see 2, 5, minus 8, 6, 5, and then 3, 4, minus 5, 2, 5. So this is the matrix E. RREF, reduced row echelon form of the matrix E, is this matrix. Here you can observe that you have pivot position in the first column as 1 and the below entry are 0, 0. Then you have the pivot position in the second column 1 below 0. Then you do not have pivot position in third and fourth column. So directly you have the pivot position in the fifth column. So this is the reduced row echelon form of the matrix, which is of square or the rectangular size. Now let us find the rank. Now what is meant by rank? Rank means the dimension of the column space, or you can say that the number of pivot positions in the reduced row echelon form or the row echelon form of the matrix A, because that is going to determine the basis for the column space of the matrix A. So let us find the rank for the matrix A, which is A is given. Now here we are not finding the row echelon form, or in the first question I'll tell you that we are just going to verify in the first question if you want, and then we can go ahead. Okay, let us do it. 1 0 minus 2. So this is the matrix A, and let us find RREF. We are not asked to find the reduced row echelon form, but we are just verifying the number of pivot position and the rank, which is dimension of the column space of the matrix. Reduced row echelon form of A is this. That means 3 pivot positions are there, and for rank the command is RANK, rank A. The commands in Scilab are very easy to remember because it is not something very different from the actual term. So RANK, rank in the bracket A. So the answer is 3. Means 3 is the rank, dimension of the column space. That means the basis set contains 3 columns, which spans the column space of the matrix A. Now the next question is, let us do the C question, and B, you do it the B question. Now C is 0, 1, 3, minus 2. No need to verify here, we can directly find the rank. Okay, just wait a minute. Okay, the next is 2, 1, minus 4, 3, then 2, 3, 2, minus 1, and then we have minus 4, minus 3, 5, minus 4. So 0, 1, 3, minus 2, 2, 1, minus 4, 3, 2, 3, 2, minus 1, minus 4, minus 3, 5, minus 4. These are the entries. So this is the matrix of order 4 by 4, and rank of this matrix is, we have taken C. So rank of C is 3. That means only 3 columns will be having the pivot position. So let us check. Let us see for our knowledge how we can see RREF of C. So the pivot position is in the first, second and the fourth column. So third column is not a pivot column, and therefore the first, second and third column will form basis for the column space of the matrix C. So as I have said that you should have knowledge of the matrix algebra, so concepts will be more clear if you solve here, because computation part is 0 for us because we are using commands to solve the questions, but concepts will be more clear. Thank you so much. We will continue in the next lecture.